All right, the next section we're going to be looking at is one dealing with implicit differentiation. Okay, so let's take a look at that one. So 7, 9, and 23 are the ones they suggest. Let's go ahead and do 9. So on 9, what's going on here is we have a function, we have a situation that would be hard to get the y by itself. So what we're going to wind, solving for y, getting y on one side, everything else on the other. So what we're going to do is we're going to use implicit differentiation. So anywhere you have, we're going to be taking the derivative with respect to x. That's what that's there for. So anywhere you have an x, it's going to be just like you expect. Anywhere you have a y, you're going to have that extra little y prime on it. So I do the derivative of x to the third, that would be 3x squared. Okay. Then I'm working on this part here, and you see this is times. And the way I tried to get you to think about it is to realize that y is some function of x. So this y right here, think of it like it's maybe a 2x minus 5 or something like that. So you're going to have to use the chain rule when you wind up doing this. Also, there's multiplication between these. So we're going to have to use a product rule on that. Okay, so I'm taking the derivative of this piece here. So it's going to be minus, that's like the constant, it's like a minus 1. And then I'm going to do the product rule. So the derivative of the first times the second as is, plus the first as is, times the derivative of the second, which would be 1. And then I need to do the derivative of y, which would be y prime. Okay. All right, then I need to do the derivative of y squared. So that would be 2y to the first power, and then y is a function of x, so I need to take the derivative of it with respect to x. And then I need to take the derivative of 7 with respect to x. Okay, so then I have a 3x squared minus y minus xy prime plus 2y y prime. Okay, these are times in here, equals 0. And now what you want to do is collect the terms with the y prime, keep them on the same side, and move the others out of the way. So I'm going to subtract the 3x squared and add the y to get them to the other side. And then at this point, I'm going to factor out my y prime. Right? When I do, what's left would be negative x plus 2y. And so I can divide by that on both sides. I'm not going to write that part. Well, I'll write it. Divide by that on both sides, which means this goes, and I have y prime equals negative 3x squared plus y over negative x plus 2y. All right, now let me talk a little bit. Let me come back up to the top part. So here's a correct answer. Okay, well, depending upon how you did the problem and how you factored and all of that, you might have a different form for that. Okay, so this is what we think our answer is. Would you recognize it if they had it written this way? Because that's exactly the same, right? I just interchanged these two terms. I kept the signs right, so that's exactly the same. Okay, so you could do that. You also could multiply through by a negative 1 on top. As long as you did the same thing on the bottom, that's also correct. So that's my worry. All of those are equivalent. And on a multiple choice test, you need to be able to recognize that. Okay. All right, so that's implicit differentiation. All right, let's go ahead and look at another one. Let's look at 23 is another one they suggested we do. Let's do one more. So x squared minus 3 natural log of y plus y squared equals 10. All right, so that 3 ln y, that is not going to be a product rule situation because the 3 does not have a variable with it. But everywhere you see those y's, I have to remember to do the chain rule because we're thinking about y as being a function of x. So we're going to have to do the derivative of it. So let's go all the way through taking the derivative with respect to x. So derivative of x squared is 2x. the derivative of the natural log of something is 1 over. I'm just going to bring the constant down. I'm going to do 1 over y. But then y is a function of x. I need to do the derivative of it. I need to do the chain rule. Remember, think of y as being something like 2x plus 5. You'd have to do the derivative of that. All right, and then y squared would be 2y times y prime, and the derivative of 10 would be 0. Okay, so I have negative 3 over y prime plus 2y y prime, and I'm going to go ahead and move the 2x to the other side by subtracting it. So I'm trying to get my y primes on the same side, everything else on the other. Then I'm going to factor out the y prime. So I have negative 3 over y plus 2y. And then I want to divide by that. So I'm going to divide by all of that. Okay, to get my y prime by itself. Now, this is not an acceptable final answer because you have a complex fraction. See how that little fraction has a denominator of y? At a minimum, you're going to need to multiply top and bottom by y. So we would get negative 2xy. And then here, when we multiply by y, we have to distribute, and we'd get negative 3 plus 2y squared. Okay. All right, so that's correct. But again, multiple choice test, watch it, because this is a good final answer. But depending upon how people move things around, somebody else might have gotten this instead. They might have gotten 2xy and then 3 minus 2y squared. You know, and I can see they're equivalent because I could multiply the top and bottom by negative 1 and make that happen. So y prime equals, could equal either of those, and they're both considered equivalent. Also this one could have had the 2y squared first minus 3 on it instead of that. Those say the same thing. So be aware of other equivalent correct answers. All right, so that's 3-5. All right, let's go ahead and knock out 3-6. 3-6 was the one that involved the inverse trig functions. All right, and I did show you how to generate those, but let me go back a minute to find the problem. Okay, 17, 19, and 27. So let's go ahead and do 19. But really, you just need to know these, the inverse trig functions. All right, so we'll go ahead and take a look at this one. So this one involves arc cosine. And this has been a long time. So it's one of those things you have to really go back and look at. Okay, so the derivative for arc cosine, I'm going to write it up here, d dx, okay, of arc cosine of something. So we're doing the derivative. I've got to get an extra c in there. We're doing the derivative with respect to x, but we might have a function of x in there, right? Arc cosine of u. So it's going to be a negative 1 over the square root of 1 minus u squared, but then you'd have also to do the derivative of u prime because of this, okay? And then you'll see that sometimes written with the negative u prime all together on top, okay? This is kind of my thought process. I do the derivative of arc cosine, which is the negative 1 over the square root of 1 minus u squared, and then I do the derivative of u, the inside function there, okay? All right, so on this one, we have a constant out in front. It's not a product rule situation because it's just a 3, not a 3x or anything. And I do have an inside function, x over 2. All right, so I'm getting ready to apply that formula. I'm doing the derivative of this with respect to x. So I'm going to bring down the 3. I'm going to do the derivative of arc cosine, which is negative 1 over square root of 1 minus the u, which is x over 2, squared. And then I need to do the derivative of x over 2, which is 1/2. And then I'm going to work on just cleaning this up as much as I can. So that would be negative 3 kind of on top, the 2 down here. And this would be 1 minus an x squared. X over 2 squared would be x squared over 4. X squared over 4 there. Ooh, I wonder how much simplifying you're expected to do on this. I guess I'll show you. All right, so this one's a little bit of an issue because of that 4 there in that denominator, and you can't just multiply top and bottom by 4 on this one. So here's one way to think about simplifying that. If I come in here under the radical and I rewrite the 1 as 4 over 4 minus the x squared over 4 to kind of combine those two terms into one expression, I'd have a 4 minus x squared, and it would be all divided by 4, still under that radical. Okay, so then I could clean it up a little bit, because that radical with that underneath it could be separated into 4 minus x squared, the square root of that over the square root of 4. Okay, and the square root of 4 I could do, it would be 2. And so those 2's could cancel out, and I'd have negative 3 over the square root of 4 minus x squared. All right, and I'm not sure how much simplifying they would really expect you to do. And I'm just pondering another way to show you how to clean that up, and I really can't see a better way to explain that. That's probably the best way to think about it at that point. Okay, so that was number 19. Let's go ahead and do another one of those. Why don't we try number 27? All right, so 27. 27 is arc cotangent. All right, so we did notice, like on the other ones, that you really only need to memorize sine, arc tangent, and arc secant. And then when you do the cofunction ones, they just have a negative on them. So you probably would have memorized the arc tangent and then just put a negative on it. And you'd know you have arc cotangent. So to start with, I'm kind of thinking of the one I know is the tangent one. And the tangent one, I would do 1 over 1 plus u squared, and then the derivative of u if I were doing tangent. Okay, so if I'm doing arc tangent, I would just put a negative on that. So d dx of arc cotangent of u would equal, and they normally put the u prime right there on top, over 1 plus u squared, no radical or anything. Okay, so that's what we're doing here. So we're getting ready to do that. Let me just write this again. Arc cotangent of 6x. So my u is 6x. All right, so I'm doing derivatives. So I'm going to do the derivative of arc cotangent. I usually think about it this way. Would be negative 1 over 1 plus 6x, the quantity 6x squared, and then the derivative of the inside function is 6. So I'd wind up with negative 6 on top, and then 1 plus 36 x squared. You can't knock the 6 and the 36 out because 6 is not a factor of the denominator. This is actually as good as it gets. So the hard part here is just knowing the formula. But again, make sure you know the formula for arc sine, right? Arc tangent and arc secant of x. Okay, know those, and then all the cofunctions just have a minus on them when you get ready to do those. Okay.